Welcome, boys. In today's lesson, we're going to talk about metals and non-metals, okay? So what I want you to be able to do by the end of this video is I want you to be able to describe non-metals, tell me what defines a non-metal as a non-metal. So that's the first thing, be able to tell me what makes a non-metal a non-metal. Be able to tell me what makes a metal a metal. And last one, I want you to be able to tell me what the noble gases are and what makes a noble gas a noble gas. All right. So those are the three objectives for today. You just need to be able to define and describe metals, non-metals, and noble gases. All right, let's jump straight into it. I want to try and keep this video short. All right, so metals. Here are some examples at the bottom. You should be familiar with most of them: zinc, steel, nickel, tin, copper, and lead. All right, the metals are usually shiny, solid, and have high melting and boiling points. So those are the three things that make a metal right there, okay? So first objective is tell me what makes a metal a metal. They're shiny, they're solid, they have high melting points and boiling points, okay? Metals are also ductile and malleable most of the time, okay? So you should probably take note of what these words mean. Ductile means they can be drawn out into wires without breaking, and malleable means they can be bent in their solid state without breaking. Okay, so malleable means you're able to bend it and twist it around into different shapes without it breaking, and ductile means you're able to stretch it out into thin, long wires without it breaking. Okay, yeah, that's ductile and malleable. Some metals can be mixed together to form a mixture called alloys. So alloys are mixtures of different metals, and you get brass and bronze are common alloys, we know. Okay, all right, so I just want to quickly run through the slide again just to recap. Metals are shiny, they're solid, they have high melting and boiling points. That you should know. You should be able to tell me what ductile and malleable means, and I'll probably ask you a question about what's the difference between the two, so you should probably be able to do that as well. And then also you should be able to tell me what alloys are and give me two examples of them. Okay, fantastic. Let's jump to non-metals, okay? Non-metals are elements that do not conduct heat or electricity, okay? So what that means is they don't conduct heat or electricity. If I put a non-metal into a fire, it does not transfer heat along it very well. If I put a non-metal into a plug socket, it shouldn't shock me very easily, okay? So non-metals, there aren't many non-metals on the periodic table, but these few elements make up most of the world, from the air we breathe to the sea, the salt on all the rocks in the Earth's crust. Okay, so basically all I'm saying is there's 17 to 19 non-metals. There's not a lot, okay? But of these non-metals, they actually make up a lot of the world we interact with, okay, such as the rocks and the earth, water, sea, all of that. Okay. Yeah, non-metals, the only thing that characterizes them as a non-metal is they do not conduct electricity, okay? Or they don't conduct heat and electricity very well. They can if you put enough heat or enough electricity through them. All right, so that's a non-metal. Should be pretty simple and straightforward. Now, on the periodic table, there's one column right at the end, and it's column number 8, okay? And it's called the noble gases. So I quickly want to show you where the noble gases on the periodic, boom, here we are. All right, so here's your periodic table. These gases down here, these are called the noble gases, okay? We're going to talk about what makes a noble gas a noble gas, but just remember, metals are on this side, non-metals are on this side, and semi-metals in between. So a noble gas is a non-metal, and it's in, all of them are in this purple color over here. Okay, so those are noble gases that all appear on the side there. These gases are unreactive, which means they do not react with any other element, okay? So other elements combine and they mix with other chemicals and they form new chemicals. Noble gases don't. They're like loners. They just chill by themselves. They don't mix with each other. They're by themselves, okay? They're unreactive. They don't react. They're not explosive. They don't dissolve. They don't do any of that, okay? They're really boring gases, okay? Noble gases also glow when light beams travel through them, okay? Or when we force electricity through them. I know we say non-metals don't conduct electricity, but they're actually bad at it. If we forced energy through them, we'd get them to glow, okay? Because they don't conduct electricity well, okay? Noble gases are non-metals, so we've said this. What I want you to know, noble gases are unreactive. What does that mean? It means they don't react with other chemicals or other elements. They just like to chill by themselves, okay? And another thing that's just cool to know about noble gases is they glow when either we put light through them or when we force electricity through them. And the examples I want to show you now are of helium. It's a noble gas. When you force light through it, it glows this color. This is helium. Okay. Neon signs. They use this gas inside tubes to glow and make neon signs like that. Argon is another one. It glows this really cool purple color. Krypton, cool, named after the superhero, the Superman weakness, Krypton. And then finally, xenon. Okay, all of them glow when lights pass through them. I just thought I'd show you. It's really cool. Yeah. All right, and that is it. We'll talk about this semi-metals next time. Have a great day, boys. If you have any questions, feel free to email me or no, WhatsApp me. Don't do that. Email me, or Hangouts, or Google Meets. All right, have a great